So in this particular class, okay, so we need to add the what here, the vectors, vector addition. Let A and B are the two vectors to be added, vector A and then also the vector B I need to what here add. Now choose any point at the P, here is the P is the any point. The draw one line the P to what here, the Q, so then it call it as an what here, the vector A. And also the point the A to what here, R. So R we can call it as an what here, the Q to what, the R. QR is equal to what I can able to say. So that is the B vector, the B is here. Q to R is vector B, such that terminus point is called as an P. Q is the origin of what here, QR. Okay. So here we have it will make an end. So PR is nothing but a what here, from here to here we can call it as an C. Then how to add this particular vector? Okay. So vector A plus what is that, vector B, then the resultant vector is nothing but a what here, the vector C. So this is how we can able to add this vector. So it binds with the one important law is termed as an what here, triangular law of what here, addition. So here we have a triangular law of addition. If two vectors are represented in magnitude and direction, let us consider two vector, A is a one vector and B is an another vector. Okay. So it is represented by the sides of a one triangle. ABC is a triangle. I will represent the vector A at the one side and then vector B at then what here, another side, and then resultant vector is always the third side of the triangle, third side of the triangle taken in the what here, reverse order. It is in this direction. A to B is, this is the direction, B to C is the same direction, but A to C, so this is the direction of this, it is in the reverse direction, not along like this. Okay, it is not goes in this manner, but it is in the reverse direction. So triangular law of a vector is says that if a two vectors represented the magnitude and the direction by the sides of a triangle, the resultant vector is represented in a magnitude and direction by the third side of the triangle taken in the what here, reverse order. So this is what we termed as a triangular law of vector. In the same manner, we have another important concept is that the parallelogram law of vector addition. Okay. If a two vectors are represented in magnitude and direction, so let us consider A is a one vector and B is another vector represented with the magnitude and also the direction by the two adjacent side of a what here, parallelogram. This is, let us consider this is the parallelogram. Okay. Their resultant represent the magnitude and direction of the diagonal. So this is the diagonal is drawn here. Okay, this is the diagonal, he is here. So the resultant is always represented along with the what, the diagonal. So therefore vector A plus vector B is always R is equal to this, R is nothing but a what here, that is the resultant vector is nothing but A plus B. So therefore what is the parallelogram law of a vector? If two vectors are represented in magnitude and direction by the two adjacent sides of a what, parallelogram drawn from a point, the resultant represented in a magnitude and direction by the diagonal of a passing through the same point in a parallelogram. So this is the two losses we have, that is a triangular law of vector and also another one is termed as an what here, the parallelogram law of vector. Okay. And with the help of this we can able to resolve the what, the vectors. Okay. Or otherwise we have another law is polygonal law of what here, addition. Okay, polygonal law we can say, or otherwise polygonal law of what, addition. So under this you see, if a number of vectors are represented in magnitude and direction by the sides of a polygon taken in an order, the resultant is represented in the magnitude and direction by the closing the side of the what, the polygon is taken into consideration. So let us consider we have so the number of polygons here. So I will just take so the one polygon is like this. So you can consider this is the polygon like this. Okay, here is the polygon. So let us consider this point is A, B, C, D, E. Okay, AB is represented by the vector A, B, C, D. Okay, resultant is in this manner. So I can able to represent this one. This is the direction of this. This is the direction here. Okay, and another direction I will take into consideration. This is the another direction. He is like this in this manner, and this will go in this way. In this way, and another one I will represent in this way. Okay, these are the direction. Okay, this is the A vector A, vector B, vector C, vector D. Then this is the resultant. The resultant vector is always represented in opposite direction. So let us consider it is in opposite direction like this. Okay, please observe the directions here. This is the same direction. This is also, this also, this also. But this one we can able to represent the resultant vector in a reverse order. Please see this. This is under the what here? Reverse order. Okay. So therefore, what is the resultant? R is equal to vector A plus vector B plus vector C plus vector D. So this is how we can able to say the polygonal law of what here? Addition. Okay. So this is if a number of vectors are represented in a magnitude and direction by the sides of a polygon taken in an order, the resultant is represented in the magnitude and direction by the closing the sides of polygon taken in a what here? Reverse order. So this is what the polygonal law of addition. So usually the vectors are resolved into, resolve means it is a splits into, we can say, into the two more vectors. Okay, what is the meaning of a resolution of or resolving a vector? Resolving a vector is nothing but the process of splitting up a vector into the two or more is termed as an what here? Resolving a vector. Okay, so how the resolving can be done? So let us consider here is an one vector. So here please observe the diagram here. Okay, OP is in one vector here, OR is in one vector. It is a resolve into the two, the OP and another one is called as an OQ. Okay. So one is called as an horizontally, another one is called as an what here? The perpendicular. Okay. If you say here is a theta, here this is considered as what here? A theta. Theta is an angle. So therefore, OP can be written as, here is an horizontal component, another one is considered as what here? The vertical component. The vertical component is always the y axis, horizontal considered as an what here? X axis. So you just see this one, the OP, how to represent the OP here? The OP is equal to OR into what here? Cos theta. This OP can be represented as what here? OR cos theta. That is called an horizontal component. And vertical component can be written as what here? PR. This is the vertical. This PR is same as what here? OQ. Okay. So PR is equal to OR into what here? Sin theta. That is called vertical component. One is a vertical component, another one is an horizontal component. This is how we can able to resolve a vector into what here? The two components. Okay. Thank you for watching the videos. Thank you very much.